Hello, Zoom people. Thank you, Michael. Thank you, everyone. My name is Igor. I'm a founder of refactoring. Yeah, and this is a sales talk. So there will be just a single slide of code. Just joking about sales, not about the code. If like at the end you will sign up to the product that is like related to the topic, that would be great. I'm slowly inviting to the beta test. And yeah, let's talk about testing in production, and that there's a better way, hopefully. And let's start with the history. It is Sagrada Familia. It's been built for over 100 years, closer to 140, I think, and still have not finished, right? And in construction engineering, I find a lot of similarities with what we are going through in the tech industry. So if it will work, yeah, it does work. In 1882, I will not try to pronounce, but Villar was the first appointed architect to build Sagrada Familia. Just a year later, he resigned, and Antonio Gaudi started the project. But interestingly enough, right, only in 1884, he was appointed the architect director. For our purposes, we'll call him a CTO. And the project is so big that like time passed, and it's completely consumed him. And in 1926, he died, with the project being done only for 25%. In 1936, Spanish Civil War started, and the anarchists got into his workshop and destroyed all of his specs and like mock-ups and everything, all of the designs. And like for a while, no one picked up the work. And it's interesting if you see, this is the photo thing from 2020 or something, how many of the different stones are there. It's a sandstone, and 100 years ago, it was brought from one places, and it's no longer exists there. It's been sold out and so on. They try to recycle that, but the sandstone from the different places have different colors. So, and you can see that like a lot of some other things that happen, there's a technology problem, right? So they don't build that from scratch. They have cranes and they assemble that from like a big pieces that's constructed somewhere, right? So their work currently is very actively going. And in 2017, they said that we're planning to finish that in 2026, so to celebrate 100 years of Gaudi's death. And we know what happened in 2020. So as we can see, there's like a lot of outside sources that like and events that out of our control that happened, and the work cannot be just like done like all together, right? We need to be doing things slowly in pieces. So here's another example. It's 520 bridge, I think. I'm not sure how it's pronounced. It's in Seattle. So there's a two parts, right? On the right, the narrow one, it's the old bridge. And to the left is a new build bridge, right? So, and that's how we want to build stuff in parallel, right? Like that, it still can be used, and we do the refactoring, we do the better thing. So it is a longest floating bridge in the world. Another interesting stuff about the planning is they started planning to replace this bridge in 1997. Who can guess when they started to work on they started working on that only in 2011. And so they started doing that, and they ordered pontoons, that's what they call it. So they ordered from the supplier. And as soon as 2012, cracks on them started appearing. So, and it like will reduce their lifespan way past 75 years that they were projected. So like, of course, there's some developers who done some things on their own. So they said that, well, it's the contractors who done the shortcuts to complete that, to meet the deadlines that we set. So they started rebuilding them and like repairing, and the repairs pushed back from the project from 2014 that they originally planned to finish to 2016. There's external factors have not stopped, right? In 2015, there was like 2 accidents and the construction slowed for like a safety measures, right? So again, there's a lot of external factors. And the interesting part is like in general, how the bridge, which is built and like the roads now, like West Gate, we don't stop the existing working solution before we're ready to release the newer version, basically. So when they released that in 2000, opened the bridge in 2016, they slowly shifted lanes from the old bridge to the new one. So what, there's a sudden change to why these things are complicated, right? Like to build and to do these things it's about the confidence of the like things you're doing, right? And we're here to talk about the code, right? And I don't know about you, but like in my opinion, changing the code is easy. You just go and change it, right? But changing or rewriting or doing the factoring with confidence that you don't break something, that is a hard process. Right, so we'll start with talking about refactoring and the rewrite. So there's like startups are built, and they usually build in Rust because they're trying to find product market fit. They're trying to build the features, they build the pivots, their old code is still there to support the existing customers. And there's a lot of change, a lot of things that technical debt and everything built not to scale, right? Like we all taught not to do like optimization and things like that. So if we will go closer to refactoring, right? Why developers are afraid of like doing refactoring, so doing the rewrite? Ideas to this one? Yes. Yeah, that's a part of that. Like I will definitely, like it's on my list. Any other suggestions? Yes. Yes, that's pretty much like 2 of the main ones that I have. Is like the first is like it's unexpected, right? You came to like 7 years old project, and when they were growing, some person wrote that 5 years ago. Now you need to fix that. The person is not here. Maybe they wrote that only 2 years ago and they're still here, but they don't remember what happened 2 years ago. So like technically no one knows how it works, right? And the second point, it's important. It's like critical piece, right? Like we don't want to break important stuff. So our CEO was screaming of us of like hey, downtime. I hope everyone is doing blameless postmortems. And that's like I think that's what customers hate, right? It's not the pricing. Pricing is good. Like if they pricing, like if they paying you already, it means that it's useful for them, right? But what they really hate is when their workflow that they come every day and use your software and it's broken, right? Something unexpected. So from my experience, when I was the CTO previously a while ago, one of the teams will switch in JSON serializer, and that's for like third-party integration. And JSON serializer is like not that hard, right? It's different implementations, right? But like apparently, what like new one decided that if the value is nil, they just don't put the key there, and it broke the like third-party integration for one of the customers, right? And that's usually the case, right? That the code that really needs to be refactored is fragile. It's a mission critical, and no one wants to touch it. Sandy Metz calls that Death Star anti-pattern, and like she goes as far as to say like everyone has this problem. And like, what do we do to gain the confidence? And I think like the first thing that comes to mind is that's what tests are for, right? Who are 100% confident in their tests? We have one person, but I'm sure if there will be like zero coverage, he would be still confident.
But I think Anton.
Yeah, and actually, like, there's some people, like, there's one person just to for the report, for some people who said that they're confident. And I know there's a few people out here who have 100% test coverage, and they still haven't raised their hand, right? Like even with 100% test coverage, they're not 100% confident. And that's what we do, right? We write a lot of tests while we develop features, and they grow. We see bugs. We do like regression testing and like integration testing, and they're like just like a whole thing grows. And let's talk about test plans, right? Are there any problems with tests? Yes. Yeah, that's a good point. You have to write them. Any other, Michael?
They tend to be.
That's a great point. That you can only test what you can imagine, basically, right? Like what you can think of. Yes, over there. Can you? Mm-hmm. Mm-hmm. Yeah. Yeah, so like if I understood correctly, that the point is like when you write tests, it's also like this the thing that you came up with, and if like the next person comes up with the test can contradict with like a new requirement or something. It's like most of it. Yeah. So yeah, like, and that's my actually like a very first point, right? The tests problem with them with like data quality, right? They're synthetic, they're pure, they're not substitute for the real world. Yeah, I've been vegan for 5 years. Recently stopped, and like mock products are not there yet, and neither are tests, right? Like they cannot cover production. How many of your tests like cover historical data in like regressions and what your system looked like 7 years ago? It's really rare. No one like came up with the solution. And like tests are not modeling the production data, right? They model what is the current state of the ideal. No, like we do like database queries, right? Like it's sterile. There's no other thing in there. And the next is like it's on the best effort, right? And yeah, like Ruby is way better than many other communities in testing, right? But I don't know, like for open source, right? Even if there's a test, if there's like very well-known companies like Shopify, they're using software and they're in the README, like not production ready, even that they like running that in a production, right? And like I'm for one, not sure why my first story points ticket with critical piece of like production ready, bug free, and like from like first attempt, just ship. You know the other tests that you write something, like you change the logic, and you like, I fixed the bug, and you test your fails. And you read the description and like comments around that, and it's like preserved for backward compatibility. And you're like, all right, so that's the cases where it's like people already used to this bug, and you cannot fix that because they integrated with that, and there's a lot of them. Some people call that backwards compatibility. So yeah, again, like tests are there at the best effort. And there's a few more, right? It's costly. Like writing the test itself, it's also like generally for productivity. Running them, they might be slow. More you have, like slower you are, like people just like, I gave up, I just like push CI will do that. But like even CI, we have like parallel runs and it still like takes long. And people start deleting the tests for old data. And then lastly, it is costly. This time it's literally, right? Like it costs money to run the CI. The bigger test suite you have, the more you spend on it. And especially when developers just like, I'll just push to test it faster on the CI, right? And let's come back to like a first point on the data. So I think we as engineers should rely on data a lot. And for this talk, I would probably only concentrate on the 2 points, right? We need to look at the inputs in the context of these tests, right? That's what we talked about, the data quality, right? Do we have enough use cases with the new code refactoring or rewrites covered, right? Are we confident that we touched everything, all of the edge cases? And the second one is outputs. And not the outputs of like our code itself, which is also like part of that. Like, is the new code, if it's a rewrite, does the same thing, just better in like lower memory consumption. It is faster, for whatever, it's more scalable, you define your. But like, how do you know if you don't measure that, if you don't have it? So that's where people went to testing in production. And it's not as scary as it sounds nowadays, because Google said that do that, and everyone's like, yeah, let's do it. So let's start with the definition, because there's a lot of different definitions. That one is defined by Optimizely, the company that's doing A/B testing, right? And it's like testing in production is a software development practice in which the new code changes are tested on the live user traffic rather than staging environment. And that's a status quo, right? And the status quo is we pretty much know feature flags, canary deployments, and A/B testing, right? And I like really don't understand how it became acceptable, right? That's just like, let's ship a like buggy software to like subset of users, like they will deal with that. Like with doing research, I've done like compared a lot of competition and so on. And one very popular feature flags company, they had a webinar, and like in the webinar, they shown how they can put like a subset of users into like a new feature that they tested. Right, and they're saying like, oh, we can use the country as an example, and they chose Canada as an example. I don't know why. Maybe they hoped that they like noticed that broken software and apologized for breaking it. I don't know. That's American. They like Canadian jokes. But like even like other parts, right? Like a feature flags is pretty much like if condition, right? If you do that for like a refactoring and you ship the code, how do you know that it's like let's talk performance, that it's better? APM monitors and like APM solutions like Datadog and AppSignal and New Relic, they're great over like whole system, right? But like your specific change, let's say you have a search with like 50 fields, right? And you have specific customer that like use that in a really weird way that takes down like in the 95th percentile, they just like now it's like not 200 milliseconds, it's like 5 seconds, right? And you go and you refactor, and on a smaller subset of your local database, it's not noticeable, but you think, I fixed that. And you ship it, and APM is like, yep, it's great. And I fixed that. You know why it's been fixed? The customer left, right? Like, there's no problem anymore. The solution was not better. And like, we cannot do that if we test separate things. Right? And if we do agile with like feature flags and other things, usually rewrites or refactoring and so on, like behind the feature flag, it's like big bang release. We replace that when we're ready, right? There's no incremental things. You can do that, right? Like feature flags is like just a tool, but like usually it's just like, let's hide that until there's a redesign and all the bugs now there because like you test that on the real world. So there's some companies that are doing that differently. And science, because it works. Just the old, it's a very, like one of the best ones, like XCD bonus. It's just like number 54. So there's basically a scientific method and been for a while around, and we started formulating the question. And we form the hypothesis, and we do the prediction, and we start testing them, and we analyze it, right? And as a developers, I think we just like, that's all we do. We make a hypothesis, and that's part of our workflow. And like back to this like status quo, right? Like there's like with the breach of shifting, it's more of a feature flag and so on. In the real world, there's not that many examples where you can actually do the same thing twice, right? In the software, we can do that. In the practice, you cannot send the same car on the 2 bridges simultaneously. But like, I'll try to like give some examples, right? Like in DNA, so like blood samples, right? You can have like a same blood from the same person to the 2 different dishes and like apply that vaccine, compare, right? Or imagine you are like photo printing shop, right? And the person comes to you with a thumb drive and you print, and you bought this new awesome printer. What you can do is like copy file to the 2 print on both of them and like look at them and it's like, oh, like the blacks on this like new printer is not that good. All right, so you can compare and you destroy that, you give like original one to the customer. And the next customer comes and like wants to print a free document. And you're like, oh, that like new printer does not even can do that, right? And that will make sense later. So like steps to the big rewrites, right? We just like, we'll start with like writing the new functionality. And we migrate legacy data because the data is problematic part. There's a lot of it in a production usually. In a successful startups, probably like terabytes of it. And you, like over time, since you like originally migrated and you fix new things, the data will diverge, right? So what you do, you find like new cases and you do double writes, sorry. And you migrate again. And after that, you dark ship using like a feature class or whatever. And you find the bugs in the original system because hopefully the new implementation is better, and you decide what to do with that. Like you either keep that compatibility or it's an edge case that no one ever found. And that's where we come to the sciences. It's a Ruby library for refactoring critical paths. It's been released by GitHub back in 2016, like 6 years ago. And it didn't get much traction. But the idea is built on top of a pattern called branch by abstraction. When you introduce the abstraction as a proxy in front of that and adding a new implementation and shift the traffic, basically, right? And scientist is not for like writing the tests and not supposed to replace them. And like to be clear, like all of the previous complaints about the tests, about the APM and the feature flags and A/B testing, and even canary deployments, I think it's all of that is great. It's just like not solving specific problems. It's presented like many of these things presented as too broad, and we try to adjust this. Like we have a hammer, let's like rewrite using the feature flags. And the canary deployments. I don't know when we decided it's like, yep, let's shift to 5%. 5% is quite a lot. And like, look at 500s. Like you already have corrupted data potentially. Like it will take weeks to restore that. Yeah, I don't know. Anyway, so the library, and this is my single slide of code that I promised, is very simple. And that's the case. I'm building a product around that and done a lot of customer development. Not many people know about the scientist, unfortunately. And it's always like the implementation is so simple that people just like dismiss or like it's just an if statement and so on. That's why I've been talking for half an hour about the problems, right? Because you need to understand that it solves specific use cases and it helps you. So if I'll like explain briefly, right? Like the science comes from the scientist and you just like name the experiment, right? And you have multiple blocks. You have one use block. That is your old code that you've been running that you know that is good, but slow, for example, right? And you have a new implementation, and that's a trial. But what is happening is like when the requests come to the web server, to the action, we randomly execute them, and we always return the result of the use. The try is sandbox, so there's no like exceptions going out or anything. And at the exit from the science block, we can do a few things, right? Like we can compare the results of them and check that they the same. We can compare the timings and a few other metrics, and we can publish that somewhere to like StatsD, Prometheus, Datadog, what have you, to the logs exception and yeah, like when I was saying about feature flags, you can still like roll that up for like the feature flags. You can there's a more DSL for that to like enable that slowly and increase the percentage. And yeah, that's pretty much how the scientist itself looks like. And it's been used in production for a while by GitHub, Trello, Marvel, RealGeeks, and like many others. I spoke on the last meetup with a few people from Up, at least a few teams there using that. I'm pretty sure Shopify is using that because they very actively like contributed to it. Yes, and like there's many more because if you look at the implementations, there's of course in like I counted like 50 ports to the different languages. And here I want to cover some myths. that like through me talking to the potential customers that came up. And if you read any article about the scientists, they also come up. So the first one, you can do it with sandbox and staging. Yes, you can duplicate the request to the staging, but there's a few things that makes it complicated. You need to treat your sandbox as or staging environment as a production. Otherwise, you become obtuse. And you need to sanitize your data. You need to run it, and you need to have a lot of, like if you compare in the performance, for example, right? It will not have the same load. So your database might be not under the load to show you the differences. It might not have the same data because you only applying the backup from like half a year ago. And there's so many edge cases that it does not cover. Static types and compiled languages help with that. Well, they not, because nothing says about any incoming data from the outside world of like third-party APIs sent to you, of the your data that like sits there, and maybe if it compiles the reports before the end of financial years, like when they generate it, you will find that the data is not compatible. That it's not relevant to high load, because if you do like a lot of writes, they overlap, and like in your second one, there will be a difference. GitHub done and extensively spoke about at least 2 refactorings that they've done. The first one, over 3 years, they've replaced their permission system, and they found a lot of edge cases and so on. And as you can imagine, the permissions on every page checked, and there's a lot of high load. So there's a great talks about that by Jessica from like a big Ruby thing back in 2016, and a few other people spoke about the scientists. I think Zach Holman in PHP Australia was talking about it too. Another refactoring, interesting refactoring that we've done is this merge button that you click. At the time of this refactoring, they had 12 million users. So if you have at least the same amount, it's fine to use. So I don't have 12 million users in the projects I've worked on. So the next one is only for refactoring. That what I was also believed in, but like people come up with interesting ideas. And what I found, when you have these 2 very senior developers that argue about the way to do something because of the performance, you just ship 2. So there's no control, you just compare them. And you can prove that with science. And the last one, and the biggest one, is cyber, right? So everyone's like, yeah, you run these things twice. So yes, you need to be careful, but it's not like it's not suitable for that. I used that to replace ORS for like user signups, right? I was switching from active records to SQL, and you just in SQL have users to table, and you compare the results from the output. And when you're ready, you switch in the tables and drop the users to. Like there's a lot of these use cases when you send some payment information, you're probably not testing HTTP layer. You're testing like a new way you constructed the payload or something. If you do like, I don't know, like CSV exports, and you compare them, your sidekick or background processing generates them to put to the new S3 bucket before sending an email, compares them, right? There's, you need to be careful, right? But all of these examples with merge button is, it's like a literal Git thing. It's like there's so much I/O is happening, and you still can do that. And the permissions, right? The permissions it's like testing setters and getters, right? Without the getter, you cannot check that the setters is working. So you compare the side effects through every place where you read this. In the case of the permissions, they found that, oh, we're actually losing the permission when we transfer the repo, or when the team is deleted. There's like some places where it's like not updated like permissions, and they fixed the old system, and it was working in a new system, and they migrated data again, cleaned up the data, and eventually fixed everything. That was a really brief explanation of like what scientists do, but like again, I wanted to show more of like as a pattern on what it's doing, and I have only one part about my company, what I'm doing. So at the end of these experiments, right, you have some results, and then locally it's easy to check them. As soon as you ship, it becomes problematic, because you need to maintain your InfluxDB, you need time series database, you need to think about the data and how you send it. You need to build your own graphs with like Grafana or Datadog. There's a lot of these things, and every time I consult someone and use the scientist or the places I worked, it's not your part of like your business, so it's easier to like one of the feature flags companies or your exception monitoring companies, and if you do the refactoring, to have a UI for your things. So there's like a statics, there's a graph on the performance comparison, there's a graph on checking how many of the things matched, mismatched, or like any new code is error. And when you go into that, there's a this. And the this is like a very problematic part, because at one of the companies, we started shipping that to the logs, and very quickly went over our limits of our farm in the logs. We tried to switch to exception monitoring, and people freaked out that the site is down. So there's not really a good visualization strategy. So that's what I hope to do, and do the scientist better include it. And it's called refactoring. And that's the end of my presentation. And today then, if you want to sign up to the beta list, there's a refactor.ly is the website, and you can find me all of the links to everything at igors.me. I'm Igors on GitHub and IgorsGeek at Twitter. Thank you. No. Yeah. One second. What I was wondering, when you basically have my test system, if you want to compare the outcome of so there's some similar so like the comparison is basically done in the part, right? Like, when you do the refactoring, you still write the new code, right? You're just not replacing. You this is not very useful, right? Like how you do it. This part is like model check, right? Like this whole thing is method code. So I just read like I rename the original method to _o and define the original name new method with default like this, and do the name of the full method new with the new utilization. And you very quickly, right? Like it's technically it's like writing. It's not really writing a test, right? It's more like you allow the users to generate the data because they already do that, right? But comparing to the feature class, they don't execute it, and you can compare, right? Like your database on the same node. It's at the same time, so like the time is all bugs and so on. Like it's not the statement when there's like a different data. If you're trying to like repeat the request against the staging and you feel like people change something, so there's a mismatch. Because it's shaken at the same time, it gives you the results. And so it's not the test as a part of the CI, it's already in production. But the good point, I think the good point about the tests, right? If you actually found something unexpected, you might want to go back and write the tests for like your regression so you don't break that again. I mean, I'm not sure if it's answering the question, but like there is some boilerplate involved in making the experiment, but it's not really like testing the, it's a following the spec of the original implementation. That's what it's just doing. Any other question? Yes.
I want to comment that as someone
yeah. 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 Yes. Yes, there's a, yeah, that's usually the case. In the sense of with any new like technology, you need someone who will be like ambassador of that. And like for me, the biggest part was to maintain all of the infrastructure and that, having like a good UI and like integrate with the system. And yeah, like I'm just scratching my own itch by building the product. All right, thank you everyone.